So today we'll be starting with managing input and output operations. As we have discussed in the previous classes about arithmetic operators available in C programming, not only arithmetic, all the operators available in C programming. Now we'll be discussing about managing input and output operations. So what do you mean by input and output operations? Input means we want to enter some data. It may be from the keyboard or a mouse or any other device, whatever it may be there, and we want to display some data. For example, it may be your name, or you want to display the list of students, or the names of the marks of the individual students, or the list of the employees who are working in the institute or college, and so on there. So we want to display in a particular format, maybe in a particular format, in whatever way you want. So for that there are different operations or operations are available. Yes, basically there are two functions are available, printf and scanf. What we will be discussing that shortly. Yes. So here the outline of the entire chapter: introduction, streams, formatting output with printf, then how to print integers, printing floating point numbers, printing strings and characters, then other conversion specifiers, printing with field widths and precisions. We want to print 8 digits or 4 digits and so on, using flags in the printf format control string, or printing literals and escape sequences, and formatting input with scanf. So these are the topics what we'll be discussing in today's session there. Yes. Presentation of results with scanf and printf. How to use scanf and printf? So here input and output statements are: your scanf is an input statement and your printf is an output statement. So here to use these functions we need to include one header file, that is #include stdio.h. So it's one of the header file where we need to use whenever you are using printf and scanf functions, they are the functions, we need to use a header file. Similarly, there are plenty of header files available, like for example you want to use mathematical functions like maybe finding square root or sine, cos, tan, and so on. So you have got math.h. And similarly for string functions, manipulation of string, string copy, string length, concatenation, you have got string.h. Similarly conio.h, and so on there. So there are plenty of header files available, so we need to use those header files depending on your applications. So here we will be using your stdio.h is a header file which includes your input and output functions, scanf and printf. So whenever you are using printf and scanf, always you need to include a header file called as stdio.h. Otherwise your program may not execute well, you may not get the desired results there. Yes. So what do you mean by a streams? Streams is nothing but sequence of characters organized into lines. Your program is nothing but a stream, what you can call. It consists of large number of lines of codes, what you can call. Yes, and always the line ends with a special character called as new line character. Yes, line justification characters ends with new line character, /n, \n, what you can call, that is what you can call a new. So always a line end with a new line character. So ANSI C supports lines of at least 254 characters. Performs streams. What we can do is streams. It performs all input and output in statements. So your standard IO devices, your input devices, your keyboard, with the help of keyboard you will be entering the data, maybe your numbers or maybe your names or characters, whatever may be there, and where it is displayed on the screen or the monitor, what you can call that. So these are the most commonly IO devices what we are using commonly. And errors, where the errors are displayed again on the monitor or the screen, what you can call. So keyboard is a input device and your monitor is a output device, what we can call, and your errors are also displayed on the monitor or a screen, what you can call. Yes. Now formatting output with printf. We want to display the data or information in a particular format. Whenever you want to display the format, it may be, for example, you want to display only integers, or you want to display characters, you want to display 10-digit salary, or your character should be at the center of the page, or that is for example heading of the topic. The topic heading should be at the top of the page and should be centered. How to do all these alignments? So for the alignment of all these things, we are having a statement called as printf statement. It's a function or a statement, what we can call. Yes, precise output formatting. So in whatever way you want to display the information, you can display with the help of printf statement or a function. So conversion specifications, flags, field widths, precisions, etc. So what we can do with the help of printf, we can display the width 4-digit number or a 10-digit number, or I want the fractional values to be only 2 digits, or I want to round it off to the 2 digits, or I want to round it off to the entire integer, all those things. Precisions, field widths, rounding, etc. It can perform rounding, aligning columns. It should be right justification or left justification, inserting little characters. Suppose you want to display some title which should be enclosed within double quotes, that you can do. Exponential formats, or you want to display the data in the hexadecimal format or octal format, and fixed width and precision, whatever the width, 2 digits, 4 widths, or 2 decimal points, and so on. So you can display the data in any format. That is what you can do with the help of printf statement. Syntax or the format of printf is printf format control string and other arguments, and it should end with the semicolon. So format control string describes the output format. Suppose for example you want to write welcome to the C programming. Yes, that is a output format. Yes, and other arguments, it's a option. If you want, you can use it, otherwise you can leave it there. Yes, in some cases, suppose you want to display the integers, so enter n integers. So what is the value of n? N may be 5. So you want to display enter 5 integers. So that is your n becomes other argument, 5, what you can call. Yes, so 2 arguments is for the first is the if you want, you will be using it, and the second is option depending on your application. Format control string describes output format. Other arguments corresponds to each conversion specification in format control string. That is, in the control string, if it is integer, integer number should be there. If it is a character, it should be a character, float or float, and so on. That each specification begins with the percent sign, ends with conversion specifier. See, all the format control string begins with the percentage. Suppose you want to display integers, percentage d, float, percentage f, character, percentage c, string, percentage s. So all the format control string begins with the percentage, and it ends with the conversion specifier. D for integer, s for string, c for character, f for float, and so on. That we will be seeing it shortly. Yes, integer. What is first we will be discussing about how to display integers, how to print integers. So what do you mean by integers? It is whole numbers, no decimal point, basically no decimal point. Example, 25, 0 or -9 and so on. Positive, negative, or it may also be 0. Only minus sign prints by default. So plus 25 will not be displayed, or by default it is always positive. Only if it is minus 25, that will be displayed. Example, that is what. Yes, so there are different types of conversion specifiers are there. Yes, when you use percentage d, as I told you, it display a signed decimal integer. It may be positive as well as negative, but only negative sign is displayed, whereas positive sign is not displayed. Plus 25, only 25 will be displayed. Minus 25 will be displayed, but plus sign will not be displayed, only 25. So by default it is always positive. Then I, percentage I, it displays a signed decimal integer. Even you can use I and D specifier different when used with Scanf. When you use with Scanf, I and D are different, what you can call. Yes. O, display an unsigned octal integer. Base 7 it is, 0 to 6 you can use it. Base 8 is octal, so 0 to 7 you can use it octal. Base 8 it is, so 0 to 7 maximum octal numbers. Display an unsigned decimal integer. When you use percentage u, it is unsigned, only positive decimal integers. Capital X or small x, display an unsigned hexadecimal integer 0 to 15, whereas 10 represents a, 0 to 9 are same, 10a, 11b, 12c, 13d, 14e and 15f, 0 to f. So base 16 it is hexadecimal number. It can 0 to 9 and the letters a to f to be displayed, and x causes the digital 0 to 9 and a to f to be displayed. So x represent hexadecimal number. Then even you can use h or l. It can be placed before any integer conversion to indicate that it is a short or long integer. H represents short and l are, we want to represent how many digits, length 4 digits, or it may be 10 digits. So you want to represent the length, you can use h or l. So these are the some of the conversion specifiers that are available in for printing integers. Yes, we shall see one example. So using integer conversion specifiers, so here we use hash include stdio.h integer main. So as we are using printf statement here or a function here, always we need to include a header file hash include stdio.h. so integer main, so printf percentage d new line backslash n is a new line character. So you want to, so the slash percentage d slash n is a format control string, and your other argument is 455. What do you want to print here? 455 is your number, it is of type integer. Then percentage I, so d and I are same here. Percentage d plus 455, percentage d minus 455, percentage hd 32,000, percentage ld long integer, short integer, percentage o octal number, percentage u is, then percentage u unsigned numbers, percentage x hexadecimal, percentage is hexadecimal. We shall see the output of. So we want to display all the statements here. Yes. So first one is 455, first, second and third. So it plus sign is not going to print here. We can see in the third output statement plus 455 you have given, but still it will just display as 455. Yes. Then minus 455 as it is displayed, 32,000 short integer and long integer as usual. Then 455, it is a decimal number and it's we want to convert into octal number. Automatically it's going to convert into octal number and it's going to display the number as 707. Yes. Similarly 455 again in is that's what unsigned integer it is 455, minus 455 again it's not in the range, so it's going to display in with help of a negative sign. Then 455 in hexadecimal it is 1C7, and again capital X, lowercase s and capital X both are hexadecimal numbers, so there is no difference, so we will get the number as 1C7 there. So this is how you can use the printf statement for displaying the integers. These are the integer conversion specifiers. Yes. Next we will be going for floating point numbers, printing floating point numbers. So floating point numbers, they have a decimal point. Floating points are number now, they are having a fractional values or a decimal points. Exponential notation E format, 150.3 is 1.50 into 10 square. So but even we can represent it as 150.3 is 1.503 e plus 02 in exponential form, where e stands for exponent. You can use either lowercase e or you can use either uppercase e, both are same. So floating point numbers you can represent in the normal form or also you can represent in the form of exponential form, both are same there. Yes. Yes. Printing floating point with at least one digit to left of decimal. We want at least before the decimal point there should be a 0.3 is valid, 0.3 is invalid. In that way always there should be after decimal point minimum one digit should be existing. In 0.3 is valid. Yes. Floating point having decimal, yes, same thing. Yes, fine. Yes. Then floating point with at least one digit is G. Even you can use G. Printf, it prints in F or E with no trailing zeros. Suppose 1.2300 becomes 1.23. If any zeros are there, those zeros will be eliminated. So if you use G, small g or capital G, both are, it's not what is going to be used for printing floating point numbers, but zeros will be eliminated there. Yes, use exponential if exponent less than -4 or greater than or equal to 6 digits by default. So the value is a larger value, so then you use exponential format. Or if the value is very simple, like for example 10.56, so you don't require any exponential form. So when the number is too small or when the number is too large, so better use the exponential format. Yes, that is how you can use print the for floating point numbers. Yes, so we'll see one example with this. Yes, floating point conversions. Yes. Yes, example. Some again here, as we are using a printf function, we need to include stdio.header file. Yes, floating point conversion specifications or specifiers. Percentage %e 1 2 3 4 some number we are going to print. Yes, it's a integer number, sorry, floating point number with a sign, a positive number. Again same thing with plus sign we have given percentage %e, percentage capital E in the form of exponential we want to print, percentage f, percentage g and percentage capital G. So same number in various format, all are valid format. E is the exponential format, lowercase e or uppercase e, percentage f is a float number, percentage g which will eliminate the leading trailing zeros, what you can call. We'll see here. So first one 1.23 E006. See the value is 1234567.89. It is represented as 1.2345. So here both are, the first two numbers are same, because here the only difference we are given the plus sign, but plus sign will not be printed in the output statement. Then the next also is, as we are given minus sign, minus 1.2, same. Then the fourth one is capital E. Again it's the same thing, 1.3 instead of lowercase e, capital E is there. Then the fifth one, f is there. See, you'll be having, when you use the floating point, always you'll be having 6 decimal digits, 1 2 3, same without exponential format. If you use percentage format, it will just be in the with having 6 decimal digits. After the decimal point there will be 6 digits will be available there. Yes, so that is what 890000, but you use in the exponential format, or that will be there in the E format. Yes, then the next is G. G, what's happening? So percentage G and percentage capital G, both are same. Again it will represent in the form of exponential format, same as small e there, nothing difference. So both are same there. Is it clear? So this is the difference between what you can call the floating point. Different types of specifiers are there: percentage E, percentage E, capital E, percentage G and percentage capital G. All are the what you can call specifiers for printing floating point numbers. Yes. Yes. Next we'll be going for displaying the strings, what you can call printing strings and characters. So whenever you want to print a string represents again a group of character, or we want to print a single character like A or B or C. So it prints. So we will be using percentage C for printing individual character. Prints character argument C when you use the. So as you discussed, always all these specifiers are preceded with the percentage sign. So percentage C is going to print a character argument. It cannot be used to print the first character of a string. Yes, so we can print a single character, but when there is a string we cannot use C. So yes, percentage yes is going to print a group of characters. When you want to print your name, for example Polytechnic, yes, government, something, it's a group of characters. So whenever you want to print an entire string, so we need to use a specifier called as percentage yes. It requires a pointer to character as an argument. So prints character until null character is encountered. So always the strings are terminated by default with the null character. All the strings are terminated with the null character. So whenever you are doing any string manipulation, you can compare with the null character, which indicates the termination of a string. You can read until you can use in a while loop till check till the null character is occurring. If there is a null character, that indicates that what you can call the string is been terminated there. And the percentage yes or the specifier cannot be used to print a single character. Percentage yes, if you give and you want to print the letter as p, which is invalid, you cannot use percentage yes for printing a single character. Yes, note single quotes for character constants. So whenever you are using characters, always the character should be enclosed in a single quotes. Whenever you want to print percentage a, percentage c, which is of type character, it should be enclosed in a single quotes there. And double quotes for strings. Whenever you want to use to display the string, it should always enclose in the double quotes. For example, even a single character z can be enclosed in the double quotes, but it will be treated as a string but not as a character. Government, for example, so it should be enclosed in the double quotes. Polytechnic, whatever any string we want to display, it should always be enclosed within the double quotes there. Yes, so double quotes for string, single quotes for characters. So double quotes for string, which actually contains two characters, that is slashes and backslash 0, that's a null character. Always the string terminates with the null character. Yes, so printing strings and characters. Again, as we are using a printf function, always we need to include a header file, a hash include stdio.h. Yes, again integer main. So here we are printing character a, character string of array. The square bracket indicates a string is the array. Again it is of type character. So what we want to store in the array, we want to store a message as this is a string. It's a group of characters. This is a string. So entire line or four words has to be stored in a array called as string. Then constant character string pointer, this also is a string. So it's also one of the pointer variable. So we want to display that also. Yes, three characters are available. Yes, first printf percentage c character, percentage s, this is a string, percentage s string, then percentage s string pointer. We will see how it is going to print. Then as you are using a new line character, always if you don't use the new line character, what's happening is in your output, all your output will be in the single line. As you are seeing here, the output is occurring in each new line. Why? Because of the new line character. As you are using percentage c backslash n, that indicates after printing a character, your cursor will be going to the next line, then the second line will be printed, this is a string, and similarly again the string, and next again the string pointer. So if you don't use backslash n, what's happening is your what you call the output will be in the single line. So you cannot the result will not be legible for you. You cannot understand you cannot get you will get the results, but it will not be very legible. Yes, so the first output is a, as you see printf character a, so output is a. Next, this is a string percentage s, this is a string second. Yes, third string, so you are storing this is a string as a inner array, so string you are going to print percentage s string. Yes, string. Then the string pointer, this is also a string, that is you are having a pointer here, so string pointer, this is also a string. So this is how the characters are percentage c percentage s are used for printing a character. See, as this a is enclosed in the single quotes and this is a string is enclosed in the double. Any string should be enclosed in the double quotes, whereas character should be enclosed in a single quotes, what you can call. Yes. Yes. Then there are other conversion specifiers, like for example p displays pointer values, n it stores number of characters already output by current printf statement, how many characters you have displayed, maybe 10 characters. Yes, then printf statement, it takes a pointer to an integer as an argument. So it takes a, what is a pointer then? Pointer is nothing but an address of a variable, what we can call. We will be discussing about the pointers later. So nothing printed by percentage n specification. Every printf call, it returns a particular value, how many characters it has been displayed. It may be 10 characters or maybe 20 characters, or entire number of characters as an output there. Negative number if error occurs. Suppose if the printf statement is not displaying properly, yes, so it will display, it will give a negative number. If the printf statement is executing properly, it will display what you can call the number of, it is going to return the number of characters displayed. So for printing you always require a percentage sign, percentage %d, percentage %f, percentage %c, and so on that. Yes. So some of the example here is we want to print the pointer. Yes, in integer pointer, integer x is equal to 1234.45 and v. The pointer is equal to ampersand x. So what is the value of pointer? The value of pointer is some address value. PTR is nothing but the value of address value. Yes. Then what is x? X is ampersand x. It indicates the address of the pointer. So both are same here. Yes. The address of x, the value of pointer is some value, PTR is some variable. So we want to, it's a pointer variable. Yes. So address of that is being printed here. Then what is x? Ampersand x will give the address of the variable x. The address of x is stored here, whatever it is. Yes, that's what is going to specify it here. Then the printf, total characters printed on this line. How many characters have been printed? So 41 characters. So total characters printed on this line is 41. That is percentage. Yes, d. We are going to total printed on this line is percentage d. You specify that. Yes, dot v, v here. Yes, v is equal to printf. This line has 28 characters. Yes, this line has 20. So 28 characters were printed. Again we are displaying percentage d, 28 characters were printed. It has been displayed here. Yes. Then printf a percentage in a format control string. Yes, printing a percentage in a format control string. So this is an example as we have seen it. Yes, that's what the use of the printf functions are. Yes. Now we want to print the numbers in a field width and precision. You want to specify 3 digits, or we want to specify 4 digits, or whatever may be, or sometimes you want only 2 fractional values, 0.00, only 2 digits we want, because by specifying float we will be having 6 values. We don't want to have 6 fractional values. We want to have the nearest 2 values what we need to have it. That can be done with the help of printing field widths and precisions. Field width, size of field in which data is printed. It may be 2 digits, 4 digits, or whatever. If width larger than the data, by default it will be write justified. If the width is, suppose you specified 12 digits, yes, but your data is larger, more than that. So what happen? If width is larger than the data and your data is 4 digits for example, so your data will be write justified. If field width is too small, it increases to fit the data. Minus sign uses 1 character position in field. Yes, so if you use minus sign, it's going to take 1 character position at a time. Yes. Integer width inserted between percentage and conversion specifier. So how many digits of data you want? 4 digits for example, percentage 4d. So width of your data is only 4 digits. You cannot have 5 digits of data. That is what you can have it, only 4 digits of data, or percentage 8d. So your integer should be of maximum of 8 digits. You cannot have more than 8 digits. So whatever you want to have, the field width should be specified between the percentage and the delimiter. Yes. Similarly for precision, so precision means number of decimal digits after the decimal point, fractional values. So meaning it varies depending on the data type. So depending on the application, the what you call the field width differs for precision values. For example, you want to calculate the results, which student is securing more marks. So in such cases you require more number of decimal values whenever there is a comparison. Yes, for example, if you are having salary column, you may round it off the fractional values to the next nearest integer. In such cases, so the precision varies from the from application to application. Integer default minimum number of digit is 1, to print is 1. If data is too small, so it will going to prefix with the zeros. So floating point number of digits to appear after the decimal value. So it may be E and F. So for G, maximum number of, how many digits you want to have, maybe 2 digits or maybe 5 digits or whatever depending on your application. strings, maximum number of characters to be written from a string. So suppose there may be a 100-word character, so you don't want to display 100 all the characters, you want to display just only 20 characters, that can be done. So maximum number of characters to be written from a string. A string, there may be 5 lines of data may be there, you want to read only you want to display only 1 line, that also is possible. Yes. Then printing with field width and precision format, so we also use the dot operator after the percentage point 3f. It can be combined with field width percentage 5.3f, 5 digits and for what you can call the whole number, and the 3 digits for the fractional values what you can have. So dot operator can also be used for specifying the how many digits you want to have for the fractional values. Yes, can use integer, even we can use integer expressions to determine field width and precision, even you can use asterisk also. So negative field width, it always, when you use a minus sign, it is always left justified, and when you use positive sign, it is always right justified. So you should specify example maybe percentage star comma star f. So you want to print a floating point number, so star 7 digits, fraction values 2 digits, so example may be 98.736. So it can be in general format can be star comma star, what can, even that also is allowed. So we will see one example here. Yes, using precision, include stdio, a hash include stdio.h. So as we want to use printf function, always there should be a header file stdio.h. Yes, integer I is equal to 873, double f is equal to 123.94536, and string character s is a array, happy birthday is a string we want to display. So printf, this is a message using precision for integers, that will be displayed as it is using precision for integers. You see here printf is t, what is slash t again here? So slash t is a tab, you can see here after here there is a space of blank spaces of 8 digits, you can use slash t, as in the previous here you are using new line, so that also after that a new line is going to come here. So both are valid, that is what you can use here, or you can use it here. Yes, that's what. Yes, slash t, the tab space, then 0.4d, you want decimal 4 decimal digit, but here you are having 873 is a 3 digits number, so here it is you want 4 digits number, so it will display, add a 0 to it. Yes, leading zeros will be added to it. Similarly 9d, your decimal is of 9 digits, but you are having only 3 digits, so remaining 6 zeros will be added to it. Yes, that's one. So next, that is for integers. Then using precision for floating point numbers, again same message, using precision for floating point numbers, you will get it. See what is the value you are given, 0.3f. Yes, you want the floating one, you want 3 decimal digits, 123.945. see after, so here there are 5 digits are there after the floating point, you want to print after the decimal point only 3 digits, so 123.945. yes. Similarly 0.3e, you want to display in exponential format 3 digits, 1.239 exponential 02. If you want 4 digits, you can specify 0.4 there. Then 0.3g, yes, it's 124, it's going to round off to the nearest value 124 there. Yes, that is what you can use it. Then using precision for strings, how to display the string? So happy birthday 0.11, yes, you want to display only 11 characters, so 3 plus 2 5 6 7 8 9 10 11. So here happy birthday is suppose 5 space is also be character treated as a character 6 7 8 9 10 11 12 13 14. 14 characters are there in entire string. Out of 14 characters you require you want to display only 11 characters. So t is a tab 8 spaces, percentage 11, yes, so only happy birth, what you can call, so only 11 characters. You want, you can specify any characters, but here as you want to display 11 characters, so that will be display only 11 characters is going to display. And here in all the programs you are going to use a return 0. If you don't use, you will be getting a warning called as your function should return a value. So to avoid that warning, you can specify the value as return 0 there. So you are not going to return any value, so it should be specified as return 0. So these are the some of the statements what we need to discuss about in a printf statement there. Some more examples how to printing literals and escape sequences. You want to print sometimes special characters like single quotes, double quotes, maybe new line character or enter key or something like that. So most we can print most of the characters can be printed whenever we want to print a null character. Null also is a literal what you can call. So in such cases it should be used with the backslash. Yes. So certain problems such as the quotation mark, you want to print the quotation mark. So to print that we need to use a backslash. It must be represented by escape sequences. So it is represented by a backslash followed by an escape character. Backslash double quotes, backslash single quote, backslash new line character, something we shall see the table there. Yes. So escape sequences, backslash quote, it's going to display a single character, backslash double quote, it will display the double quote, backslash question mark is going to display backslash is going to display the backslash character, backslash a some music audible bell or visual alert, b f n is going to next and so on. That b is for one position to the current line back to the start of the next logical page, n to the beginning of the next line backslash n, r move the cursor to the beginning of the current line, t horizontal tab position, v move the cursor to the next vertical tab position. We can use v as well as t. So these whenever you want to print all these things you need to use a backslash as a character there. Yes. Yes. Next is about your formatting input with scanf statement. So whenever you want to what do you call so we have so far we have discussed about the output statement. Now we will discuss the printf statement is the output statement. Now we want to discuss about the scanf statement. So scanf is whenever you want to read the data from the keyboard we need to use a scanf statement. What we can do, so you can input any formatting of data. Scanf is again a function or a method function to read the data from the keyboard or any IO devices. So it is used to input all types of data. It input specific characters, skip specific characters and so on. So those are the capabilities of scanf. Again the format of scanf is same as what you can call the printf statement. So again whenever you are going to use the scanf statement always you need to use a header file stdio.h file. So syntax is format control string and other arguments, where format control string may be which describes the formats of input whatever may be the input, and other arguments may be your pointers to variables where your input will be stored, like for example ampersand a as we have seen, or it's nothing but address of the variable v where we want to store the data. It can include field widths to read a specific number of characters from the string. So that is the format of your syntax of a scanf function what you can call. Yes. So there are different conversion specifiers are there, same as you have seen in the for integers for printf, the same will also be used for scanf. D for integers, I for octal or hexadecimal, O for octal numbers, then U for unsigned decimal integer, X or capital X for hexadecimal integer, H or L for short or long integer to be input. Same all whatever you used in the printf function, the same can be used here also. Then similarly for floating point numbers, E small e exponential f float, G or G is floating point, L or L is long float or double what you can call. Whenever you want to use double it should be L or LF what you can use. Then for reading a character, %C and %S for reading a string, and all the strings are terminated with a null character. Then %C and %S for as usual. Then we want to use some scan characters, like maybe for P for reading an address from the that is been for when you use %P in a printf statement. N is used to print the number of characters, or when you want to read the number of characters from the printf statement, or skip a % sign in the input. So some special characters are available. Yes. Then formatting is set of characters enclosed in square brackets. So always even in the scanf statement we use percentage sign there. It scans input stream looking only for characters in the scan set. Whenever a match occurs, it's going to store character in a specified array there. Yes, so square bracket indicates array. Suppose in the example we have seen a string as the array, we want to store some of the names in the string. So if the string array is found, in that what you can call all the numbers are, all the characters are being stored there. It stops scanning once a mismatch is found. Suppose if the array is not there, then it's going to stop scanning there. Yes, then inverted scan sign, we are having some special characters A, E, I, O, U. It causes characters not in the scan set to be stored, what you can call. Yes, then it's some skip characters can be skipped using include character skip in form. When you use percentage sign, you can what you can suppress some of the characters, skips any type of character without, so you don't want to store any characters, so you can use asterisk as a symbol there. Yes, so reading characters and string, an example, hash include, again as I told you is a scanf statement. So we need to read the data by using as it's a scanf is an input statement, we need to use a stdio.h file. So main character x y of 9. Yes, y is the array having size of 9. So printf enter a character, scanf percentage c and percentage s. So if you are using percentage x as a character, so you need to have a address of x. But when you are using y as array, you don't need to have address of y, just you need to specify the y, the name of the array. So printf, the input was, so enter a string. Suppose you might have enter a string as Sunday. So the input was the character yes, it will print, you are going to print x, so it will take only first character, and the string was unday, so remaining character. So first character is going to is displayed in the x, and remaining characters are displayed in what you can call a string called as y. So this is how you can read the data from a scanf statement there. Yes, this one more example is, yes, so with this we can wind up that what you can call your scanf statement is used for reading a display displaying a